Hayden surveys 93 students at random to determine the proportion of students who have attended Mount San Jacinto College for more than 2 years. Suppose that in reality, 55% of students have attended for more than 2 years. So what this problem is going to ask us to do is to think about the proportion of students that Hayden surveys that attend more than 2 years compared to the actual population proportion, which is 55%. Okay? So for part 1, we're going to let the random variable p hat be the proportion of 93 randomly sampled students who have attended Mount San Jacinto College for more than 2 years. We want to know how p hat is distributed. So here, this is the sampling distribution from the central limit theorem. Okay? So from the central limit theorem, we know that the sample proportions are normally distributed with mean the same as the population proportion and the standard error equal to square root of p times 1 minus p over n, where p is the population proportion and n is the sample size. So to fill in these two blanks here, we need to just calculate these values from the central limit theorem. So first off, what's our p? What is our population proportion? Well, it tells us this in the problem. It tells us that p is 55%, right? Suppose that in reality, 55% of students have attended for more than 2 years. That is the population proportion. That is what the actual proportion of students who have attended for more than 2 years is in the population. So 55%, we want to write that as a decimal. 0.55. So that is our first quantity here. That's our value for p. Now to find the second quantity, that's going to be our standard error. We are going to use this formula here. Okay. Now for this, we will need n. We already have the p, but we need n. And we know from the problem statement that we're surveying or sampling 93 students. That's our sample size. So n equals 93. So put those together, and our standard error is going to be 0.55 times 1 minus 0.55 over 93. Okay, so our standard error is the square root of 0.55 times 1 minus 0.55 divided by 93. Just applying the formula here. And so our standard error is 0.0515877. Okay? And so that's the sampling distribution we are going to use throughout this problem. Now let's answer a few questions. What is the probability that fewer than 48% of students in Hayden's sample had been enrolled for more than 2 years? Okay? So we already answered part 1. Now let's worry about part 2. For part 2 here, we want to find the probability that fewer than 48% of the students in Hayden's sample have been enrolled for more than 2 years. So that means the probability that the sample proportion is smaller than 48%, or 0.48. Okay? So to find this probability, we first need to find the z-score. Just as usual when we're dealing with a normal distribution. Okay, let's find the z-score. The z-score is going to be our particular value that we're interested in minus the mean of the distribution, which for this sampling distribution is the population proportion, over the standard deviation of the standard error. So p times 1 minus p over n, all under a square root. Okay, so let's throw that into a calculator, see what we get. So this is for our z-score. Okay, in fact, let me put a little break in between there. So our z-score here is going to be, in fact, let's call it z1 because there's multiple parts of this problem. Okay, so this is the first z-score we're calculating. and we're going to calculate our p hat, our particular value, which is the boundary value here. That's 0.48. That's the particular sample proportion that that's the threshold that we're concerned about, right? We are interested in the sample proportions that are less than this particular sample proportion, that particular value. So 0.48 minus our population proportion, which is 0.55, and we're going to divide by our standard error. Now I could write the whole formula out again, or I could just use the variable that I've already stored that standard error in. So I'm going to divide by SE, which is the value of our standard error. And so the z-score that I'm interested in is negative 1.35. Okay? And now using that z-score, I can find the probability, because now this probability in our sampling distribution is also equal to the probability in the standard normal distribution that a randomly chosen z-value is less than our z-score of negative 1.356913. Okay, when we're dealing with a probability in the standard normal distribution, we use the p-norm function. Since we're interested in finding the z-values less than this particular z-score, we don't have to do anything special. Okay, we're just going to use the p-norm function as it is, plug in our z-score, which I've named z1, and that gives you the probability that we get a randomly chosen z-value less than this z-score. So that's our first probability. There is about a 8.7% chance that in Hayden's sample, the sample proportion is fewer than 48%. Okay? Let's look at part 3. Part 3, what is the probability that more than 58% of students in Hayden's sample have been enrolled for more than 2 years? Okay? So let's go on to part 3 here. We want the probability that the randomly chosen sample proportion in Hayden's sample is larger than 58%. Okay, so now we need the z-score for this guy. We're going to use the same formula here. The only thing that really changes here, in fact, is the particular value, 0.58 instead of 0.48. Okay, so for this second z-value that I'm calculating, this second z-score, I plug in my particular value, which for this probability is 0.58, minus the mean of the distribution, which is the population proportion of 0.55, divided by the standard error, which I have stored in a variable, SE. Okay, so the z-score here is 0.581534. Okay, so the probability that a randomly chosen sample, that the proportion from a randomly chosen sample is bigger than 0.58 is the same as the probability that a randomly chosen z in the standard normal distribution is greater than 0.581534, our z-score. So now let's go ahead and calculate that probability. Now, this probability, we're using a greater than symbol, so we're interested in the probability in the upper tail. Our p-norm function only by default calculates probability in the lower tail. So to calculate that probability in the upper tail, we take all 100% of the area underneath our normal distribution and subtract away that probability in the lower tail that we don't want. What we'll be left with is the probability in the upper tail. This is always how we calculate probability in the upper tail, 1 minus the p-norm function. Plug in the z-score associated with this part of the problem, and I get from my probability 0.280443. So there's about a 28% chance that when Hayden collects a sample, the proportion of students that have been enrolled for more than 2 years is bigger than 58%. Okay? One more calculation here. Number 4. What is the probability that between 48% and 58% of students in Hayden sample have been enrolled for more than 2 years? So now we want to know the probability that the sample proportion p hat is between 48% and 58%. Okay? Now, those numbers look familiar, don't they? 0.48 was the value I was interested in part 2 here. 0.48. And 0.58 was the value I was interested in part 3, which means because I've already been interested in those two particular values, I've actually already calculated the z-scores for them. This z-score associated with 0.48 is the z-score I first calculated in part 2, and the z-score associated with 0.58 is the z-score I calculated in part 3. So the z-scores I'm interested are the z1 and z2 that I've already calculated. z1 was negative 1.356913. And then there's another z-score, which is my z2, which is 0.581534. I separate them with a comma. Okay? Which means the probability that in Hayden's sample, his sample proportion is between 0.48 and 0.58 is the same as the population in the standard normal distribution, that a randomly chosen z-value is between negative 1.356913 and 0.581534. Okay? Now that we have the z-scores, we can calculate the probability. Since we're calculating the probability that we're between two values, we are going to first calculate the probability, the area to the left of the larger z-score. The larger z-score in this case is z2, because that's the z-score associated with the larger particular value. Okay? So z2 is going to be bigger than z1. Okay? You could also just look it up, right? z2 was 0.581534. z1 was negative 1.356913. So this is the bigger z-score. z2 is the bigger one. So that's the one that goes first. We calculate all the area to the left of the bigger z-score. That's too much. So let's subtract the extra, which is everything left of the smaller z-score. Okay, this is always how we calculate the probability in between two values in the standard normal distribution. P-norm of the larger z-score minus p-norm of the smaller z-score. Let's evaluate, and our probability is 0.632155. There is about a 63.2% chance that in Hayden's sample, his sample proportion will be between 48% and 58%.